So this is basically what we're gonna do, all right? Maybe I'm gonna repeat it. So what we're going to do today, we are trying to learn the titration. This is the technique. But the actual reaction is the neutralization of the acid by the base, which is sodium hydroxide. We know one of those chemicals, we will be able to find the concentration of the other. After you do the titration, okay, when you're going to do the titration, you will be able to find how many ml, because we're going to dispense it, right? We're going to dispense it. So you have to find out how many ml you dispense. And this is going to be the liter. That is going to be the liter. You see here molarity. Molarity is mole per liter. We want to find the number of moles of sodium hydroxide. We have the molarity. We're going to know and find out how many milliliter is dispensed. When we're going to multiply the two, that's how we're going to find the mole. Molarity is equal mole per liter. When we multiply those two, we will be able to get the mole. Remember when I told you about the triangle with the density? Do you remember that?
Yeah.
All right. So we're going to use the same thing. We're going to use the same thing here. Look at it. This is the actual mass. Remember the mass density here, mass over there with the density, and volume is here. And I said if we want to find the volume, we hide it. And we have mass over density will give you volume. Or you hide mass, you're going to multiply those two. So this is multiplication, this division. Do you remember that?
Yeah.
We're going to do the same thing for the molarity, because also it has how many? It has 3 variables, right? 3 variables. So we can again use the triangle, right? So over here is the mole. Here is molarity, and this is the symbol for molarity, and here is the volume. Okay? When I want to find number of mole of NaOH, I hide the mole. Hide the mole. What do we have to do to find number of moles? Multiplying volume by molarity. This is our division. Do we have molarity of NaOH? This is the molar, that's the concentration of NaOH. We do have it. Are we going to be able to find what is how many of sodium hydroxide dispensed? Are we or we are not? How many ml we are going to dispense from this burette, right? So the volume also there. When you multiply the two, you will get the number of mole. That will give you the number of moles sodium hydroxide. Because it is 1-to-1 molar ratio, you will be able to find number of mole of acetic acid. Multiplying by the molar mass will give you the mass of acetic acid titrated with the sodium hydroxide. Is everybody clear about this? You're going to do it yourself, right? You're going to go step by step, and you will be able to comprehend what is it going on. It's always very important that we know what you're doing. Like we know what we are doing, not just you memorize and then you go without knowing why we are doing that. Why? Why do we have to do all of this? Because we want to find the number of moles of acetic acid, and this is what we need. And when we have number of moles of acetic acid, moles, all right, multiplied by the molar mass of acetic acid will give you gram, right? And at the end, we want to find percent by mass of acetic acid, and this is your final result. That's what you have to put in your data result, right? Sometimes people will go through all of that, but they don't show the result. So definitely the report is not complete. Okay? You have a question for what we are doing today? So every single table should have those, what you need. So the first thing we need to measure the mass of each one of those 3 Erlenmeyer flasks when it is empty. Then you are going to measure 5 ml from the vinegar under the hood, add 5 to each one of those 3. Then you add to each one of those 3 50 milliliter of water, not tap water this time. Remember last time when we had to put it in because we were using it for boiling. Today it is a quantitative analysis reaction, not qualitative. So we need to make sure that the water is clean, everything is measured as much as we can, precisely. And then after you have 55 each one of those, don't forget the dripping, like the phenolphthalein. Because if you don't add the phenolphthalein, color is not going to change. You're not going to see the end point. And you're not going to see the changes of the color. Make sure that you add couple drops of the indicator, okay? And then you're going to start the titration, all right? Follow, there is like very, very clear, let me see the page number. I just want to direct you to the right page number. So the page number that it's telling you about the procedure of this experiment, there. Where is it? Like, I don't know, it's missing. What is the page number? 28. It's only very small paragraph. Explain to you how to put 5, then you add 50 ml, and then you start like in a titration, okay? Is there a question for me here? I mean, I'm going to go through everybody's table and we will see how you're doing, all right? Okay. You have everything you need. I prepared this one, guys, for you. Maybe. Can I have everybody's please with me for a moment? Moment. Please, everybody, hello. Yes. All right. So this is done, right? So this is one of your peers who done with that. They prepared 3 of them, and this is one of them. It has the 5 ml of the unknown vinegar. It has 50 ml of water, and it has 3 drops of the indicator, which is phenolphthalein. This one has been calibrated, filled up to this, and then now we're going to start titration. The technique is very simple, but it's need to be, like, you need to learn. So usually we have one hand holding the flask, the Erlenmeyer flask, the other hand is holding the knob. And we're going to open it. It says usually, like, in the titration, every 1 ml, you start every 1 ml and you swirl. So I'm going to dispense as much as I can, 1, maybe 2 at a time, and I keep, you see here, I'm not going to stop swirling. So, and I look at it, and then afterwards, after a couple drops or couple mils, you're going to see that the pinkish is going to retain longer. And you have to be careful then, because that means maybe we are reaching the end point. And you see here, can you see the pink? Yeah. But it disappears as soon as I swirl it. It disappears, doesn't stay. So I'm going to keep adding, and then most likely I know how many ml from the previous class, but for you have to be very careful when it is going to be retained longer. That means we are reaching the end point. Try to be probably with the drops, like slower drops, drop by drop, holding the knob because you don't want to miss the end point. 1 drop will make the whole entire differences. When it is going to stay, that means you reach the end point. So I'm going to make it slower. Yeah, and I'm holding it. So the minute I see the pink does not disappear, I stop the dripping, and then I read the burette, how many ml I dispensed. So we are almost there. Don't worry, we are almost there. It is going to probably take the whole entire burette, sodium hydroxide. So it's almost about 50 or 49, something like this. So this is how it is. Like this is how you see, this is the technique of the, like the titration. It's staying longer. I'm still swirling. Bless you. So you see here is how long it takes. It actually stayed longer. So I'm gonna be very careful, and then maybe one drop will keep it, and sometime it disappear. Give it another one, just one. That's it. It shouldn't go. If it goes away, I give it another one. But some people, it should be okay. But anyway, here. That's it. So as long as it is still, that's why it's better to put a black, like, dark, white paper underneath it, or this paper towel, and then we are reading it. So the reading here, it says it goes up to 48. So that's 48 milliliter that we dispensed, and the color is still there, and it is not disappearing, okay? So after you finish the first one, you do the same thing for the second, add it back to the 0, adding more sodium hydroxide, and start the titration, okay?